size is 30. And this is what type of test are we doing? Are we doing a two-tailed, a left-tailed, or a right-tailed? Mine's a right-tailed. Greater than, mu naught. Okay, this should always match your alternative. And I calculate. And I get a t-test statistic of 10.9545. Pretty large. So I'll talk about that here in a second when we finish our steps. Step 3 was determine the critical value and make a decision. Okay, so step 3. Okay, on the critical values for the Z and T test, you're always going to draw a picture. Okay, the Z test and the T test are both symmetrical. Okay, now you're finding what's called a critical region. So where we get the critical region from is the alternative. My alternative tells me it's a right-tailed test, so my critical region is here in the right tail. If this would have been a left-tailed test, it would have been in the left tail. If this would have been two-tailed, it would have been both. Okay? And what we're going to look for is a critical value of T. Okay? Now, in order to know a critical value of free, we need to know what the degrees of freedom are. And I believe Dr. Mosley explains those. But those are always n-1. So in this case, our degrees of freedom is 29. Okay, where we get our critical value is from our T table. So we look at our T table. Up at the top, you can see it says one-tailed or two-tailed. Ours is a one-tailed, and these are the different alphas. Ours was 0.05. And you go down the side to your degrees of freedom. We go all the way down to 29. And down alpha 0.05, where those intersect, is 1.699. That is our critical value for T. Okay? So what we do now is we look at our test statistic. Okay? The T distribution still has a center of 0. So this is a positive 1.69. So if you'll notice in the T table, these are all positive numbers. So it is symmetrical. So if this would have been a left-tailed test, I would have flipped this over here and made it negative 1.699. Okay? But it's right-tailed. So now I look at where does my test statistic fall? When I determine the critical value, this region here I shaded is called the rejection region. So think of this as a number line. Wherever my test statistic falls, if it falls in my rejection region, my decision is to reject the alternative. If it falls in the non-rejection region, then I do not reject. So 10.95 is clearly way far to the right of 1.66, right? It's way out here. And I usually draw my test statistic up here. Clearly within my rejection region, right? It's probably further out. So my decision based on this is to reject H naught. Okay, and I'll explain what that means in step 5, so bear with me. Okay, now step 4 should give us the same decision. We look at the p-value and compare it to alpha. So where your p-value comes from is your calculator gives that to you. So our t-test statistic goes right here. The p-value is right underneath it. The p-value is a probability. So wherever this falls, the p-value is the area in the tail from the test statistic. So since 10 is so large, this is going to be real tiny. And it's always going to be less than 1. So when you look at p-value and you see this 4.0, if it's above 1, always look over here. It's in scientific notation. Times 10 to the negative 12. That means I have 11 zeros in front of the 4. So my p-value is equal to 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 4. Very, very small number, right? So our decision on the p-value is we're going to reject the null if our p-value is less than alpha. So in this case, my p-value is 0.006, 4. The question is that less than 0.05? clearly it is, right? So yes means we reject H naught. Okay, if it was not, then we do not reject. So our two decisions are either we reject H naught or we do not reject H naught, right here. Reject H naught or do not reject H naught. We never say we accept it. So it's kind of like the court system. When you're either guilty or not guilty and the jury finds you not guilty, that just means that they didn't have enough evidence to prove you guilty. No, in the court system, we never prove anybody innocent because you're assumed to be innocent. Same thing true hypothesis testing. We assume the null. We never prove it. We just try to find enough statistical evidence to prove the alternative. So in this case, since we rejected H naught, that's kind of like a guilty, we had enough statistical evidence to prove this alternative. If we would have said do not reject H naught, meaning if it would have fell here or the p-value was larger than alpha, and we said do not reject H naught, it just means we don't have enough statistical evidence to prove this. We assume this one to be true. We never prove the null. Okay? So that's step 3 and 4. Step 5 is our conclusion then. Okay, in our conclusions, we will say at the 5% level of significance, and here we either say we do or do not have enough statistical evidence. Excuse me. We either have enough evidence or do not have enough evidence. So since we rejected, that's like guilty, we did have enough evidence. So we do have enough statistical evidence to conclude, and we have to put the alternative in words. So my alternative here is that the population mean distance students drive to school is more than 10 miles. So to conclude that the population mean is more than 10 miles. Usually in your homework problems, if you look the word that when they ask you, do you have enough evidence to conclude that? Following the word that usually is what you can put here in your interpretation. Okay? The only difference in our conclusion, had we not rejected and not found enough statistical evidence, we would have said the same statement except for we would have said we do not have enough statistical evidence to conclude that the population mean is more than 10 miles. We don't change anything else. It's either do or do not. Okay? I'll do some other examples out of the book yet.